On the Test 1 review, questions 22 through 26 are based on the following frequency distribution for scores on a math test. And whenever necessary, you would round decimals to 4 places. So let's take a look at question 22. It asks us to find the class boundaries for the interval from 61 to 70. So how I determine my class boundaries is I'm going to look at the upper class limit for the class before 61 to 70, and that's a 60. So there's a separation of 1 between 60 and 61. I just look for what number falls halfway in between these two values. So 60 and 61, halfway in between would be 60.5. So that's going to be the lower end of the class boundary, and then the upper end of the class boundary is going to be 70.5 because it's halfway between 70 and 71. So those are my class boundaries. Next, we want to find the class midpoint for the interval 61 to 70. So to calculate that, I'll take 61 plus 70 and divide by 2. And I get 65.5. If you use the calculator to do this, either you can add, hit enter, and then divide by 2, or use parentheses in the numerator and then divide by 2, all in one shot. So that's what we've got so far. In 24, it asks us to find the class width. So I'll look back at the distribution and I look at consecutive lower class limits. So I have 61 and 51, or consecutive upper class limits, for example, 80 and 70. So either way, if you look at the difference between those, you can see the difference is 10. So that's the class width, is 10. All right. So far so good. Now we're up to the relative frequency distribution. Keep in mind when you're taking your test the difference between relative frequency and cumulative frequency, because these are often confused. So relative frequency is when we're comparing the frequency of one class against all the frequencies. So to calculate relative frequency, I'm going to take the frequency for each class and divide it by the total of the frequencies. So the first thing I want to do is take a look at the frequency list that we have here, number of students, and I'm going to add up those numbers. So I have 2 plus 0 plus 11 plus 8 plus 4, and that adds up to 25. So I'll take each of my frequencies and divide by 25. First one I have is 2 over 25. I could leave it as this fraction because that's in lowest terms, or I could give a decimal, and that would be 0.08. The next frequency is 0, so I just get 0 over 25, which is 0. And the next frequency is 11. I have 11 over 25. And if you wanted to convert that to a decimal, that's 0.44. So this is a good answer, or this is a good answer. And you don't have to give both. You can choose either fraction or decimal, unless the problem states explicitly that you have to give one or the other. Let's see. Next, we've got 8 over 25. Which is 0.08. 32. And then we have 4 over 25, which is 0.16. So for the fractions, if there were any instance here where I needed to put the fraction in lowest terms, then I would do that. I wouldn't leave the fraction unsimplified. Okay, so that brings us to the cumulative frequency distribution for the scores. So the cumulative frequency gives me the number of values that are at or below the next lower class limit. So for the first group, we want to know how many scores are less than 61, and that's 2. There are 2 values that are less than 61, and they fall in this group from 51 to 60. Next, we look at how many scores are less than 71, and that would be the sum of the first 2 frequencies. So that's still going to be 2. And what I'll do is each time I'm going to add in the new group. So we have 2 plus 0 plus 11 for the number of values that are less than 81. And then 2 plus 0 plus 11 plus 8 to give me the number of values that are less than 91. And finally, we have 25 values that are less than 101. And 25 is the total of all the frequencies. So you always expect this final value in the cumulative frequency to be the sum of all of the frequencies. And that's all there is to those problems.